My name is Cory Gideon, and I want to thank you for coming to my session. Last session before the party, so challenge accepted. I will try and go a little bit quicker so you can get out of here early and go enjoy the party. As you can see on the title slide, this is Build It Fast, Make It Quick, aka being optimal, making the hard decisions. A little bit about myself. Again, Cory Gideon. You can find me at this QR code for LinkedIn, Twitter. I'm not very active there, trying to get better at it. I'm a manager consultant with Sageti Capgemini, based out of the States. And I've been in development for 10 plus years, full stack developer, now more solutions architect. And during that time, I have become a crotchety old man. Why? It's because I've seen dev teams, and I've been part of dev teams that have wasted so much time building the wrong thing, focusing on the wrong optimizations. So, a little bit of story time. I was working with a solutions architect a few years back who had, as his developer career started, he wrote this application for a large financial services company based out of Iowa. And what happened was this was not working. We were doing about 40,000 credit card checks a day, an hour, and each one of those was taking over 15 minutes. So you don't have to be a math expert. You know that is a very bad snowball that's going to be rolling down that hill. He wrote it when they were doing maybe five requests an hour. It grew, businesses grow. But we could not optimize it correctly or move forward because he was so invested in this solution, this baby that he had created. And we all know devs are expensive. And no one likes having your time wasted on doing the wrong thing, chasing that proverbial white rabbit of performance. There seems to be also, who's all on dev team, like agile teams, or are you more project team based? Agile teams? Yeah, I kind of figured. Maybe it's just my experience, but there seems to be kind of this gang turf war between the different disciplines. The devs have a different priority than your QAs, have a different priority than your DBAs, than your UX. And how can we prevent these from coloring and skewing our end product and our decisions we're making from a tech standpoint? So a little bit of what this talk is and what it isn't. It's more geared towards your leadership and your decision makers, but I think there's a lot of good information here that you can apply to, anyone at any level can apply to their daily use, even to your own personal life outside of work. I want this to be interactive. If you have anything that you want to share, different thoughts or opinions, please interject. Also, this is not a prescriptive session. I can't tell you that you're doing X. That is premature optimization. That's not going to work. You have to do that on your own based on your tech stack and your use case. What I'm hoping to accomplish, though, is provide some tools and a way to provide a different perspective for you to take and apply it to a specific problem or situation you're encountering. Also, this session isn't for everybody. You can, please feel free to go find another session if you're not getting what you want out of this one. You are not going to hurt my feelings, regardless of what that says. I'll be fine. I want you to get the most out of this conference and these sessions. All right. Also, a little bit of housekeeping. Please feel free, please review the session when you get out. There's red, yellow, green. Green is obviously the best choice, but do what your heart tells you. So what is premature optimization? Well, let's look at the etymology of what this is. So premature, happening, arriving, existing, or perform before the proper, usual, or intended time. Optimization is an act, process, or methodology of making something as fully perfect, functional, or effective as possible. So you can kind of see what this is going to do to when we put these two together. You're trying to make your code or your project perfect before it's actually necessary to do so. This does not only apply to startups, that's where I've seen this happen a lot, or technology. This includes your non-technical companies in your decisions. All organizations are susceptible to this, and if it doesn't apply to a specific business context, it applies to your personal life as well. So how many people have researched hobbies, done all your research, but you haven't actually started doing the thing? Okay, a couple. I mean, personally, past year or so, I've been really heavy into weightlifting. And it's one of my favorite things to do. And there's so much you have to learn and focus on. So let's do a little thought exercise. Which one of these is premature? Option 1, researching and practicing the correct form so you don't wreck yourself. Option 2, watching YouTube videos to learn different lists that you can do. Or 3, creating an Amazon wish list of all the equipment you might need. Again, kind of a spoiler. Which one is it? 3, that's right. Well, falling into premature optimization can lead to, in technical aspect, can lead to so many different things. But 2 of the things that I want to focus on is it can shift you from your critical issues that your code is experiencing into the new shiny object. Ooh, shiny. Everybody likes dealing with shiny things. That is, things that are appealing only to the observer. So me being an observer as a developer, I want my response time to be so much faster so I'm not wasting 20, 30 minutes waiting for my tests to run. Well, there's actually a production bug where somebody with the Discover card can't process a payment. Which one is more important? So what leads to some premature optimization? So focusing on that white rabbit of runtime. It's, even though that these functions, like if you have certain functions out there that these are likely to be made irrelevant in the future, do we really want to focus on them? Do we really want to make them shave off that 5 milliseconds? Or structuring a startup project that can scale to millions of users and you don't have a single user. You're not going to be Amazon scale that quickly. You have time. Do you need something like mutation testing? Or is end-to-end testing and unit testing enough? Do I care that this 2 plus 2 is 4 in this unit test, but do I really need to test that 3 plus 1, 0 plus 4? No. And then programmers, I've been guilty of this, we can tend to waste time worrying about non-critical parts of our programs. And these subsequent changes lead to issues with things like code maintainability and stability. So why is it considered premature? An action is considered premature depending on the specific reasons why it is done. From a startup point of view, is it premature to optimize your code if you have an established client base versus you're still building your client base? So you don't have many clients, you don't have any clients, or you have an established client base. That's going to color your decisions on what is going to need to be optimized. And is yours time, or then you have that opportunity cost of, do we spend our time optimizing our code, or do we spend that energy building our paying client base versus optimizing when you might have hundreds of millions of clients? So again, focus where you need to. And it is important to identify and implement worthwhile optimizations. And what makes an optimization worthwhile? It depends on your app and your specific data. Optimizations made without supporting data are needless and will backfire on you eventually. For instance, is an optimization in reducing API requests by 2 milliseconds really worth it? Well, it could be if you're receiving hundreds of thousands of requests a second or minute. So there are times when those are not premature. It depends on your base. So don't misunderstand me. Response time is important and should be a consideration, but it must be supported by data. And you might have heard it said, premature optimization is the root of all evil. Is it? From the man that said that quote, Donald Knuth, forgive me for my pronunciation. It's a long quote, but just pay attention to the bolded and underlined. You should forget about small efficiencies. Say 97% of the time, premature optimization is evil. But don't pass up that critical 3%. Look carefully at the critical code only after it has been identified. Key there, identified. Don't just guess, show me the proof. So how do you do that? You gather metrics, Google Analytics, logging, using K6, you're checking your response times. Make sure you're gathering the worthwhile information to make educated decisions. This is another quote by him. Worrying about efficiency in the wrong place and at the wrong times, that is the root of all evil, or at least most of it in programming. So it's all about the time. So all optimization can be problematic. Let's not sugarcoat it. It can be pointless, or that it doesn't actually help you accomplish a worthwhile goal. Notice I didn't say accomplish a goal, I said a worthwhile goal. It has to be worth it. And so another story time, previous life, I was working with a UX designer. We spent 2 sprints on gradients and rounded buttons because they kept changing their mind. Meanwhile, I was the only developer on this project. This business couldn't write a line of insurance in production. What's more important, a freaking gradient or bringing in revenue to the company by not being able to write a line of business for insurance? I could not get that across to them. So that's had a very low ROI on that optimization. It cost so much money. I think we ended up calculating it cost the company about $23 million in lost revenue because we couldn't write that line of business. And it can be counterproductive. It causes more issues than it actually solves. So what are some of the dangers? Wasted resources. Dev teams are expensive. Spending time, effort, and money into doing something that doesn't turn out to be necessary can really decrease your morale. Has anyone worked on a feature, you're really excited about it, you're almost done, and then leadership comes down right before you're ready to ship and said, actually, we're not doing that now. Scrap it. I've been there. It sucks, doesn't it? Like, well, there's 3 weeks gone, I'm gonna go cry now. Again, rounded buttons, bane of my existence. UX, UI designers, I love you, but you make me die inside every time I have to change these things. Increased mistakes. If your code is really tightly coupled, you're changing these optimizations, well, you're increasing your risk of something breaking, something going bad. Murphy's Law, it can go wrong, it will go wrong. Again, at least me personally, I've been guilty of action, let's do it. Well, I don't actually have the data to support that what I'm doing is going to solve the issue. So, oops. And upgrades, we all want the new shiny. Do we really have to upgrade it to Angular 2000 or whatever it is now? No, you don't. Is it really something that you have to have? It can lead to worse outcomes. Who's heard of the sunk cost fallacy? Okay. You sink 20 hours into something, you see $20,000 into something. Well, we're changing our direction, you're not going to get that back. Just move on. And in my experience, developers are opinionated and stubborn. I know I am. And so we want to bulldog this solution. We want to bulldog this feature down. Well, that means I don't want to change later. Well, you kind of have to. You got to be agile. You got to shift. And you can have the illusion of being locked into that course of action. Again, going back to that sunk cost. I spent $1 million trying to do this demo or this POC. I got to see it through. No, you don't. If it's not working, say it's not working, exit. Go do something else. And it's okay to admit that the course of action is wrong. If you admit that your course of action is wrong and your boss comes down on you and says you suck at your job, find a new place to work, okay? That's not constructive, that's not gonna help you or the company grow. Negative emotions. We are emotional beings, at least until the AI takes over, but we have emotions. Developers can develop an attachment to your code. We can become personally and emotionally attached to a solution because we spent days, weeks, months, years developing it, and go back to that solutions architect I told you about. And seeing this become made irrelevant or just replaced can be really discouraging. We spent so much of our time optimizing it. We need to come to the realization that programs are tools, they will become irrelevant. We don't walk around banging stuff with rocks anymore. We have hammers, we have other tools. Now, if somebody, hypothetically, somebody approaches you and says, hey, this solution you wrote a long time ago doesn't work for us anymore, which do you become? Do you immediately try and withdraw, defend yourself? Or do you try and observe what's going on? So, who here watches boxing or MMA? Anybody? A couple? Okay, so one of my favorite activities in college was boxing. I stopped because I got tired of being punched in the face. That'll happen after a while. So in boxing, when you're boxing, you have your hands up, your chin tucked. You're trying to protect your squishy bits. Well, we can have these same mannerisms when somebody's attacking our solutions and our code. Next time you're in a retro or something, or a code review, just check your posture. I bet you might see that you're kind of hunching your shoulders, you're tucking in, you might even be balling up your fists, might be on the table. That's putting you in the mindset of, I'm gonna be defensive. I need to defend myself, I need to protect myself. And one way that you can really adjust this is breathe, open your hands, put them in your pockets, put them on the table, put them on your lap. Bring your head up, shoulders back. And something I've even started doing is take a physical step back, reevaluate your situation, see what's going on. This helps you build your situational awareness. Observe the room. We can get tunnel vision on, this person's attacking me. I'm only focusing on them. Well, hold on, let me back up. I look around. Everybody's kind of agreeing with that. Okay, let's calm down, take a breath, look at the solution objectively. All right, so covered all that. What are some other causes of it? Bike shedding. So this is also known as Parkinson's law of triviality. And as with most quote unquote laws, in the professional world, this is a generalization, not an absolute truth. So what this means is you're spending a relatively large amount of time, energy, and other resources dealing with relatively minor issues, meetings that should have been an email. We've all had them. And this can usually happen because it's an issue your stakeholders easily understand. So take a look at an example. This is a riff on Parkinson's law from his book, Parkinson's Law and Other Studies in Administration. I really highly recommend that book. It's not very long. Say you're having your stakeholders and your leadership are all having a meeting to kick off a new project. And with this project, we have three options. We're implementing microservices and micro-frontends and Docker and Kubernetes on a cloud platform. Next thing to talk about is this going to be on AWS or Azure? Third, should the UI buttons be black, blue, with rounded or square corners? So the first topic, Docker, Kubernetes, complex. I don't think the people that wrote Kubernetes even understand what Kubernetes or how it works. I don't, but I'm not nearly as smart as them. Only one or two of your attendees understand that. The group is very uncomfortable discussing it because they don't know it. So they green light it, they go ahead, spend 5 minutes discussing it. Second topic, is this going to be on AWS or Azure? Most leadership will know what AWS and Azure are. So we're going to be a little more active in that discussion, and they're going to come to a solution maybe after half an hour. Third topic, the buttons. Everybody understands UI, everybody understands buttons, so they're going to spend more time arguing about this and the user experience of those buttons, and no solution is reached. They're going to schedule another meeting to do it. So what does this mean? Work expands to fill the time available for its completion. I can count on one hand in the past 6 months how many times a meeting has gotten out early. There's always something else to fill that hour or fill that 2 hours. So this is another one that kind of goes along with it, that you don't need to argue about every little feature just because you know enough to do so. So I want to be productive, I want to contribute to this meeting, I don't understand the subject matter, I'm just going to start talking about something that's tangential to it, or I'm going to do something similar to that. So a lot of times the focus will be on the trivial issues and not the important ones. So organizations tend to give a disproportionate amount of weight to trivial issues. So again, buttons. And the time spent on an agenda will be inversely proportional to the sum of money involved. So I've been in a lot of meetings with senior level developers, through architects, up through directors. How many of those meetings reached a follow-up meeting because nothing was decided? And I've been in meetings with juniors that we're done in 10 minutes. We got a solution, we're moving forward. Everyone has an opinion on how they think something should be done. And 9 times out of 10, they're the same opinion, just from different angles. And the amount of noise generated by a change is inversely proportional to the complexity of said change. And going back to buttons, it's something that everybody sees, everybody interacts with. It's going to generate a lot of noise. And then then your back-end system is going from monoliths to microservices. Not a lot of people are going to really, that aren't in tech, are going to really understand that or care. It's like, okay, great, you spent 6 months and $100 million doing this. I don't see any difference. Sayers law. So anyone been in tech meetings where it gets really heated, raised voices? Okay. I've been in a few where keyboards were thrown. The intensity of the feeling, in any dispute, the intensity of a feeling is inversely proportional to the value of the issue at stake. And that's what Sayers law is hinting at. This trivial issue represents a problem that is easier to understand and formulate an opinion about, because it requires less time, effort, or money in order to solve. And the important issue would require them to take more responsibility for their decisions. Nobody wants to stick their neck out anymore, especially with current cutbacks and layoffs. Nobody really wants to stick their neck out. And the responsible parties are assumed on these critical issues to have done their legwork and done their homework and understand why it's important. So, an increased sense of progress is also a premature optimism, can be a cause of it. So focusing on a color scheme of a website while ignoring your feature development. And I guess nobody really likes banging their head against the wall. So they want to focus on your low-hanging fruit. I don't want to know why this app randomly crashes when I'm going to add a new page or rearrange some things on the page. Also fantasizing about the future. I don't know when this became a thing, but apparently being bought by Google, Meta, that's become a valid business strategy now. Fun when that happened. So you're developing this mobile app on the focus of being acquired by a larger organization. Well, what are you trying to solve with that? Being bought by Google is not a problem. And improper prioritization. is another issue that can cause this. It's not properly considering the opportunity cost of your work. What am I giving up working on because I'm focusing on the response times of my API? This is going to lead you to trying to unnecessarily perfect your unimportant parts of your code base instead of fixing potentially critical issues or developing new features that's going to allow the business to meet their business goals. And business. We all work for somebody. We all got to get paid from somewhere. Let's make it, let's focus on how we can help the business grow. And past experience dictating our present decisions. We've been burnt by this app going down. That's going to color our perspective going forward for all new app development. And it's great to learn from the past, and you should learn from the past, but this can really have a disproportionate impact on your present decisions and behaviors. And getting perfect grades in school, for instance, that was never a problem for me because I was not a good student. But so you focus on getting perfect grades in school, and that can lead to writing perfect code. Well, what happens then? It leads to overwork. You're working 80 plus hours a week trying to get your code perfect. And it's also, you're going to miss the delivery of your feature. What do you think an employer is going to care about? Perfect code, or you didn't deliver this? There's also the social consideration of your work to take into mind, or keep in mind, that trying to conform your tech stack and architecture to others. So I want to be on the latest .NET, the latest Angular, because company X over there is doing that, and I want to compete with them. Well, you have FOMO, fear of missing out. And you can fall into the illusion of productivity, especially given the current economic environment where you're just seeing tens of thousands of devs and tech industry people being laid off. Employers are more closely watching our work. Just look what Musk did to Twitter. He laid off a lot of people because they weren't top performers, quote unquote. Now, hands-on keyboard, ass in chair does not equal productivity or valuable work. And there's also some underlying phenomena. So you're driven by an action bias. I gotta be doing something. I'm very much like that. I've gotta be doing something, I've gotta be moving, I've gotta be working on something. There are times when we feel compelled to act, even if there's no evidence that what we're doing will be providing a better outcome. And then there's also perfectionism, striving for that flawless solution when good enough is good enough. Now, there's also procrastination, which is you're working on you're working on one thing as a delay to work on something else. I am definitely guilty of this. I don't want to work on, again, why this app is randomly crashing. I'm going to pick these 6 or 7 little 1 or 2 story point ones because I'm bored and want to do that instead. And the inverse of procrastination, there's precrastination. I want to focus on doing something too early. I know that I think that we're going to run into bottlenecks on this service. So I'm going to start thinking 3, 5, 10 moves ahead instead of just trying to solve an issue that's right in front of you. Don't make a problem where there is none. And then there's also any of the previous list. In any combination, you have your emotional considerations, so you're wanting to feel good, you're wanting to look good, you don't want to miss out. Then there's your non-emotional considerations, so procrastination, failure to prioritize, not having necessary information. Any combination of these can lead to premature optimization. So some common culprits, perfectionism, as we talked about. As Voltaire said, perfect is the enemy of good. Or, in more modern, perfect is the enemy of shippable. Your users will live with it. They'll be fine. It doesn't have to be 100% complete in order to ship. Sometimes good enough is good enough, and you can tie up your loose ends with version 2. We have to stop thinking about a digital product as a physical product. We can patch. It's fine. Nobody is going to freak out because there's another update. All right, monolith versus microservice. Microservices should not be the de facto starting point, period. Monoliths are not inherently evil, period. There is a time when monoliths are okay to use. It's not a curse word. You're not going to get soap in your mouth because you said, let's use a monolith. With microservices, everybody wants to push for microservices nowadays, it seems like. But they don't pay attention to all of the extra legwork you have to do. There's a lot of initial effort in it. It'll have future payoffs, but again, there's a lot of initial effort. Monoliths, it's easy to start. It's easy to get that proof of concept out there. But it may become an issue later on and add some technical debt. So there's pros and cons of both. Don't listen to someone who says you have to do this. No, you don't. There's a good chance you won't need that level of granularity provided by a true microservice architecture. True microservice architecture, you're like 50 to 100 lines of code, and if you're more than that, you got to split it off into another microservice. It's gross. Don't do it. So, like some of the considerations with your microservices is where is it going to live? How are we going to orchestrate it? Who owns what? If you're one team owning 100 microservices, you're going to be overworked. Well, then do we split it up, have 5 teams doing 20, 10 doing 10, 100 doing 1? Where's that line? And yes, monoliths can become huge, but will your application really reach where they will be impossible to maintain? And there's also a possibility of treating them as a macro service, aka micro monolith. So improper refinement, this is a big one. Refining small bugs or features when you're unsure of how or even if these actually cause pain for your end users. Because they cause pain for you does not mean they cause pain for your users. Might not be worth it. And usually happens, when improper refinement happens, it usually leads to sloppy products and overall bad code. And focusing too much on performance, again, is really is taking that function and taking 0.2 seconds to run off of it really so much worse than using it as expected? Or is the cold start time of a serverless app worth the pain of setting up a new microservice on Kubernetes? Can we cache the data? Can we identify how many times this function is going to be run in a single page view? So if you can define how many times that's going to be run in a single page view, then you can make your decision. Again, get your data. So post hoc ergo propter hoc. After this, therefore, because of this. A happened, then B happened, therefore A caused B. Not necessarily. That is a little bit of a jump. So for instance, if you rolled out a new feature in your app, your app crashed. What's your first assumption? That new feature crashed my application. We're going to roll it back. But was it really that new feature? Or was it your server who was unable to scale to the new traffic? How do you identify what this is? It could be your server, it could be the function, the feature. That's a good place to identify or look into, or it could be your database. Maybe somebody didn't release a lock on a table. Oops, I've only done that a dozen times. So how do you identify it? Do you have adequate logging? Do you have user metrics? How are you gaining insight into what is actually happening? And some of the biggest pitfalls we can fall into as developers is jumping too quick at a conclusion. Jump the shark, so to speak. And this framework or this language takes too long to do everything. Therefore, the language sucks. Java. And a good quote that I'm gonna really mess up his name. It's Dr. Abhijit Naskar. He's a neuroscientist, writer, and poet. He has some really great books out there. I highly recommend looking into him. Here's a quote that there is no such thing as an objective truth. It's all subjective. Unless the brain finds a way to observe the universe independent of the brain, every truth is subjective truth. So what am I trying to say here? That means that you have to have the data. You can't, like, everything is subjective to you. And as a side note, as thought workers, learn some neuroscience and psychology. It really helps you understand problem solving and how you think and approach things. It's really interesting. So how you ask these questions. Is there necessarily a causal connection between these events, or is it just conjecture? What is the supporting evidence behind these events? And then explore other possible solutions. There is rarely more than one right answer. So the key is not to avoid optimization, it's to put it in the right frame of mind. You're not optimizing to ensure outperformance, you're optimizing to refine that performance. So why are you optimizing? What is the driving factor of the optimization? Will the impact be meaningful and positive? And why are you doing something if it's going to be a negative impact? It's got to be positive. Or are you just trying to delay something? Identify these answers. Answer these questions. What are our benefits? What is to be gained in the short term and the long term? What happens in the next hour, day, week, month, year after this is deployed to production? Can you quantify the end result? Can you show me that this will drive adoption by X%? Will this lower our operating costs by Y dollars? Try and find that information. What are the costs? There are always costs. There's always a catch. What resources are you going to have to spend? And a quick rant, developers are people, not objects. I shouldn't have to tell you this, so don't ever refer to your team as a resource. Their time is a resource. They are an individual. So, end rant. But how much money will this optimization cost you? How many developer hours? That's what you should be referring to when you say resource. What else can we be doing? What are we giving up by doing this? What feature are you not delivering on this quarter because you're optimizing your Kubernetes configuration? We're switching from straight Kubernetes to serverless Kubernetes using like OpenFaaS. What are you not delivering? What are you not giving me? Are you overextending your workforce? Burnout is real. Working more than 40 hours, not getting enough rest time, family time, leisure time, that is a real thing, something to keep in mind. Are you overextending your team? And what are our dangers? What's going to happen? Could you be committing yourself to a suboptimal course of action? You could be. Do you have enough information to make an informed and justified decision? Again, going back to that data, you need it. Or do you even need to be doing this, or are you just following a trend? Everybody's adopting Angular, we're on Vue. Let's switch to Angular, or React, or insert technology here. What's our likelihood of this becoming irrelevant? Just because it might become obsolete doesn't mean that it's not worth doing. But you still need to consider the benefits before it's made irrelevant. There is a shelf life on technology. And will investing X dollars save us Y dollars over the next Z years before you need to change course? Do you know that? Can you project that? Will switching to serverless Kubernetes over regular Kubernetes on AWS save us any money? Yes, no, maybe. Find that data, run some tests. Can this wait? This is a big thing. I'm impatient. I want to do the new thing now. I want to do it. And do you really have to do it now? What happens if we wait a week, a month, or a year? Can you quantify this cost of waiting? What are you giving up? Not all optimizations are premature. don't throw the baby out with the bathwater. Just make sure that you are doing your homework on what you're doing. Do your cost-benefit analysis. Consider the Pareto principle, so the 80-20 rule. 80% of positive outcomes you experience will come from 20% of the work you do. So find your data, make justified, informed decisions, move forward. Also, plan for growth. Are you writing quality code? Is it readable, testable, maintainable? Monitor, get your data. Make sure that you are making informed decisions. You can't do that if you don't know how your application is being used. So logging, metric gathering, any actionable data you can help to gather to help make your decisions. And don't obsess over abstractions. Does your code really need to be shareable everywhere? It's not reusable until it's reused. Don't think like, okay, I'm going to be using this method or this class in this other class. I might use it somewhere else, so I should go ahead and put it in the common library. No. You can refactor that later. No, good one is define an SLA. These are important and very beneficial, even if they're just internal to your own team. So I really like this tweet. It's so easy to get sucked into performance micro-optimization territory. Someone will say that method X is slow, and inevitably somebody else will point out that it really doesn't matter out of some unrealistic benchmark. Like on the third Tuesday of every March on a full moon, this doesn't happen. Great, who cares? Deal with it that one time. Measure if it actually saves time, and filter this improvement based on your SLA. Beware of the quote-unquote clever tricks. This can make your code much, much more convoluted and error-prone. More times than not, it's really a negligible improvement. And so something like don't idolize the theory or big O notation, things like that, just to justify your optimization. This is going to go from order N to order 1 if I do this. Okay, great. It's used once a day. Off hours, who cares? You don't really need to be, it's not holding anything up. You don't need to go to order 1. We can focus on something else. And this can cause you to lose sight of the problem you're trying to solve. So make sure that you're writing code first, second, code first and that works, and as others will understand, and then make it quick. It doesn't have to be clever, it just has to work. Define what good enough is. So if you find your event horizon where that tipping point is where it's not going to be an improvement anymore. So your website has a slight delay when you're experiencing an incredibly heavy load that happened once. Do you really need to focus on that? Do you have to have a full microservice architecture? Support all browsers back to IE 8 or even later, or earlier, excuse me. And how many apps does your mobile app really need to support? Identify that horizon where, okay, we're not going to support after IE 9, after IE 11, or before IE 11 or IE 9. We're not going to support 10-year-old smartphones. If anybody's using an old phone, it's understandable, but we don't expect everybody to support that. This does not mean having low standards. It just means that you are not crossing over that horizon. Identify how much time and resources you are willing to spend on X problem. What is the deadline for your delivery? You gotta keep in mind your deadlines. And there's always a cost. There is no such thing as a free lunch. But what are you willing to pay? What are you willing to give up to do this? Your definition of good enough can shift. It is not set in stone. The key point is to define that line in accordance with each project. There will be this will shift by application responsibility and purpose, and payment systems will have a different level of reliability and uptime and everything than a to-do list app. And what I'm trying, these are very polar, opposite examples, but what I'm trying to say is the definition shifts. It's not a set in stone value. And we're stop treating your digital products like a physical product. It can be patched. Tech debt. Everybody loves talking about tech debt. Tech debt is vague. This is a big part of optimization. It's also inevitable. You're always going to be incurring some debt. And it can encompass everything from dead code to application performance to dependency management and so on and so forth. As developers, we can kind of tend to view tech debt as this is evil, I got to take care of it now. Well, not everything is that urgent. This does not mean that it can be ignored. Okay, I'm saying you have to pay attention to it, but it shouldn't be put above product delivery. What do you need first? So which one do you do first? Well, how do you define it? You have to define what tech debt is for you in your organization. What is your end goal? What is preventing us from achieving that end goal? What tech debt should be higher? So prioritize your tech debt. This is web app. This is an example from a previous client I had. We had a web app that didn't work on IE8, but also the application had issues processing payments for some users from a specific region. Our technical lead at that time made us focus on IE8. We're not able to process payments, so we're losing customers to our competition. And that's, you should probably be prioritizing the unable to process payments over IE8 support. Assessing your impact. What is the blast radius of this debt? Does it only impact a handful of users, or is it mission critical? And how does it impact your business, how they work? And identify what percentage of your time is spent. So how many hours are you willing to devote to resolving this tech debt? And I really like this solution for handling tech debt that we had at a previous employer. We had 3-week sprints. One dev was on product support and resolving tech debt. They were doing prod support and tech debt through that entire sprint. And then they would rotate that. We had 4 developers on that team. 3 developers was more than enough to keep up with. We had to adjust our velocity when we did this, but 3 developers was still more than enough. So use your retros. Identify what tech debt was solved, that sprint, and what tech debt was introduced, and prioritize the tech debt as you would a feature work. So anyone a tech lead or a team lead? Okay, I'm talking to you. This is your job. You need to prioritize, accurately track, and account for the tech debt. You need to coordinate with your leadership to make those decisions. Yeah, it can be difficult. I've told a boss before, like, hey, my team needs to work on this, and they have spent the next 20 minutes reaming me because they didn't want to do that. They told their boss that they're going to deliver this feature that they did not tell us about. We need to solve this tech debt. We need to solve these issues. So tech leads, you need to take that heat from leadership and let your team do what the team does. So limiting your debt, and during your conceptual phase, UX and architecture are your best bet at solving this. UX, you need to have a clear and precise, defined list of user needs. None of this, well, we didn't do any user experience. We think they're going to use it like this. You need to tell me that they are going to use it like this. Do your research. Do your labs, your experiments. And architects, design with that. When you're designing your systems, you can kind of take into account the future abstraction and modularity. Keep that in mind. This will save you later on. Never stop refactoring. Never. This is the only surefire way to reduce tech debt. And there are definitely battles when it comes to refactoring. PMs can see this as a waste because it's not something that's fulfilling my need as a PM. Junior devs may not be able to see a better solution or any existing code, or they are tied too closely to the priority board, i.e. performance reviews tied to number of stories or number of story points resolved to sprint. And side note rant, if you as a leader are measuring your junior developers based on the amount of story points and cards they are closing per sprint, you are a monster, seek help. And your senior devs are also able to, they're too close to the code. I wrote this, I'm invested in it. It's my precious. And that could be a hit to your pride as well. Well, you gotta get over that. It's a digital product, it's fine, you'll live. Refactor does not mean completely rewrite. It can be, but most of the time it does not. It could also be as simple as just revising your project structure to make it easier to understand. And you need to balance this pressure of feature development with projections of technical debt rate. So again, tech leads, you kind of need to have a pulse on what your team's working on, what tech debt is being introduced, how does that impact the overall goal of what we're trying to deliver. And just be aware, refactoring can lead to premature optimization. It's a very slippery slope. And the cost does not stop after you go live. Always keep that in mind. There is always a cost to running code. So just how do we reduce that? All right, I did it. And thank you. I'm Cory Gideon. Feel free to connect with me on LinkedIn.